This problem involves doing an actual calculation and figuring out how many significant figures to put in the answer. So it's sample problem 1.10 from chapter 1. So I highly suggest you reading pages 29 and 30 of the textbook if you haven't already done so, to look at the rules for doing these kinds of problems. And we're going to follow them in this problem so you can see, kind of how they work. And so we're going to look at A first, and it involves subtraction and division. And following those rules from the pages I just mentioned, you always have to subtract or add before you divide or multiply. So we're going to do our subtraction first, and I'm going to rewrite it here. It's going to be 16.3521 centimeters squared minus 1.448 centimeters squared. Now, one handy thing in this problem is they've already got the units being the same. And they have to be the same units if you're going to add and subtract something. Always remember that, okay? So let's go ahead and do the math here. And then we'll talk about those rules for rounding. So what I've got is, let's see, 1409 point. Let's see. So we're going to have 14.9041 centimeters squared. Now that is not the correct answer. If I were to stop the problem right here, I've got too many significant figures here. For adding and subtracting, the key thing is to look at the decimal points. Okay, you don't really count the figures, you have to look at the decimal placeholder. And it's the one with the fewest decimal places that determines the significant figures. So that would be the second number here, right? There's 1, 2, 3 decimal places, there's 1, 2, 3, 4. So we're going to report this one to the thousandths place. So if I were to report this as the correct answer, it would be 14.904 centimeters squared. All right, and now I can do my division. Divided by 7.085 centimeters. Now the units do not have to be the same when we're multiplying or dividing, okay? But we still have to do the math with the units. So why don't we look at that first? Let's see, I'm going to have centimeters squared divided by centimeters. So this centimeters is going to get rid of one of those centimeters, okay? And I'm just going to be left in units of centimeters, right? The same thing, if I would have had 2 squared divided by 2, right, then one of those 2's would have went away, right? 2 times 2, and the answer would have just been 2, right? It would have been 4 divided by 2, which is equal to 2. So the same concept applies when we're talking about units. Centimeters squared divided by centimeters. I get rid of one of the centimeters, and I'm left with just centimeters in the top. All right, so now I'm going to do the math here. I've got 14.904 divided by 7.085. And I get a really big number in my calculator. I'm going to write quite a few of these numbers down. I got 2.1035999, so on and so forth. I'll stop right there. Now, this is not the correct answer. If I were to stop the problem right now and put a box around that and say that was my answer, I would totally miss the problem. I have to follow those rules on pages 29 and 30 in the textbook on rounding to report my answer. And so if I'm looking at the rules for division and multiplication, I just have to count the one with the fewest significant figures, and that's the total number of significant figures that I report my answer to. So I've got 2 numbers here, and let's see, I've got 1, 2, 3, 4, 5 significant figures here. 1, 2, 3, 4. 4 is a smaller number, so I'm going to report my answer to 4 significant figures. So that's going to be 2.10. That's 3 of them. Now I got to figure out what to do with this 3 using the rounding rules. Do I round it up? Do I leave it as 3? What do I do? So the first thing I do is I look to the right, and I see that that's a 5. Now, there are special rules for 5. If there's nothing to the right of the 5, then the number rounds up if it's odd or stays the same if it's even. But here I have numbers past the 5, right? I've got 599. So it doesn't. So once that's a 5 and I have numbers past it, this automatically rounds up. It doesn't matter if it's odd or even or not. That's automatically going to round up to a 4. And then that's the answer for A part. And I guess I need to get my units correct. That should be centimeters. Sorry about that. All right, now we're going to take a look at B. And so let me get us a little more room to work here. So in B, we've got some multiplication going on and some division. All right, we don't have any addition, subtraction mixed with multiplication, division. Here we just have all multiplication and division going on. So if we have this going on, you need to do everything in the top first and then divide it by everything in the bottom. Okay, and then we're going to follow those rules for significant figures that I was talking about here a minute ago. One key thing to point out, notice this is a conversion factor, right? This is converting from milligrams to grams. Now, this is how the book uses it. I like to use the T, but they actually use parentheses and multiplication when they're doing their conversions. And you need to remember that rule for exact numbers. Conversion factors are considered exact numbers. So when we report our answer and we're trying to figure out the correct number of significant figures to report it to, you do not take exact numbers into consideration, right? So this has one significant figure, this has one significant figure. I'm not going to report my answer to one significant figure just because of that, because these are exact numbers. I look at the numbers that aren't exact, and that's how I'm going to determine what to report my significant figures to. All right, so let's start working the problem. I've got 4.80 times 10 to the 4 milligrams times 1 gram divided by 1,000 milligrams. I'm going to do the top part first. So I've got milligrams in the top divided by milligrams in the bottom. That's going to cancel out, right? That's going to equal 1. So my units here are going to be in grams. So let's see what that's equal to. I've got 4.8 times 10 raised to the 4th power and then divided by 1,000. And I got 48, exactly 48 grams. That's what my calculator told me, okay? So I'm going to leave it like that. So I'm going to 48 grams divided by 11.55 centimeters cubed equals, so let's see what I got. 48 divided by 11.55. I'm going to write a bunch of these figures down that my calculator tells me. 1, 5, 5, 8, 4. I'll stop there. It gave me a bunch more than that, but I'll leave it at that. Grams per centimeters cubed. Now I got to figure out how many significant figures am I going to report this to. So I look back at the original problem, and I got to compare all those numbers and see which one has the least significant figures, not taking into account exact numbers, right? So I'm not going to consider these guys. So let's see. I've got 1, 2, 3. 1, 2, 3, 4. So I'm going to report it to 3, right? 3 is less than 4. So I'm going to round this number down here to 4.1. And now I got to figure out, what am I going to do with that third significant figure? Does it round up? You know, what do I do with it? The third one is a 5, and I look to the right of it, and I have a 5 there. And I have things past the 5. If this were just a 5, I would have to consider it odd and even. But since there are things past the 5, this immediately rounds up to a 6. Grams per cubic centimeter. And then I put my box around that because that is my answer reported to the correct number of significant figures.